Hey guys, so today we are going to be talking about the second one of our transformations. Yesterday we talked about the first, which was our translation or our slide. Today we're going to be talking about our reflections. And reflections are pretty common. You see a reflection every day when you look in the mirror. And we have two examples of reflections up there at the top with the zebra and the dog's face. So those are both reflections there. So what we're going to do is we're going to start out with some basic vocabulary because geometrically, reflections are a little bit more complicated, so we want to make sure that we understand as far as geometry goes exactly what a reflection is. So the first bullet in our vocabulary portion here says a reflection is a transformation which flips and let me erase the little dot that I drew there. A figure over a line of reflection. So it's kind of clear up in the figure above, and you can see it with the dog's face, how the dog's face is cut in half by this dotted line. So that would be our line of reflection. So everything is going to look the same on the left side as it does on the right with your reflections. Same thing with the zebra. Even though that there isn't a line here, we can draw in a line that would create a reflection between the two zebra here. So our second bullet says a reflection occurs when you find the mirror image of each point. Therefore, each point is equidistant from the line of reflection. And I can't fit all that on here, so I'm just going to abbreviate line of reflection as LOR. So now what you'll notice is on the dog picture here, every point, and I'm going to use the tip of the ears as an example, the left ear is the same distance from that line of reflection as the right ear is. So they are both equidistant or the same distance. So as our third bullet says, the line of reflection or line of symmetry is a line that divides a figure into two matching pieces. So both of the pieces are going to match each other. Now, one of the things that we are going to talk about today is our reflection rules, and you will notice that a reflection rule looks very similar to the translation rule that we talked about yesterday. So a reflection rule is written using arrow notation, and you determine what the relationship is between the original x value or x coordinate and the new x coordinate, and we're going to look at that through some examples and try to figure out what that relationship is. Now, last bullet that we have here is to determine whether reflections are rigid motion, always, sometimes, or never. Now, thinking about what rigid motion is, we talked about rigid motion yesterday. Rigid motion is a transformation that keeps the two figures congruent. So if you think about flipping a figure over a line of reflection or creating a reflection, think about whether the size or the shape of the figure changes. And of course, the answer to that is no. The size and shape of the figure does not change. You are just flipping it over that line of reflection. Therefore, a reflection will always be rigid motion. So just to summarize what we've talked about in this top vocabulary part, when we are talking about our reflections, the main thing that you need to remember is that a reflection is a flip. So you are going to be flipping that figure left, right, up, or down, depending on what axis you are flipping over. So using the basic definition for a reflection, we are going to go ahead and practice with just some basic shapes here. So I have a couple of triangles, a square, and then this little L-shaped figure that we have here. And what we're asked to do is actually reflect these over our y-axis here. So the first thing that you are going to do is you are going to identify your axis of reflection or your line of reflection. So the y-axis is this line right here. So you're going to want to take your highlighter and you're going to want to highlight that line of reflection. Now, once you have identified your line of reflection, you want to take each figure and you want to reflect it over that line. Now, using the definition of a reflection creates a figure that is equidistant or matches the other side. So what we want to do is consider how far each figure is from the line of reflection. So, for example, on the square up here, I'm going to start with this point on the square first. What I noticed is that point is 1 unit to the left, so in order to reflect it, I'm going to go the same distance in the opposite direction, so 1 unit to the right. Now, I can create the other points by doing the same thing. So the other side of my square, the other corner of my square is 2 units to the left, so I'm going to go back to my line of reflection and I'm going to go 2 units to the right. So here is my second point. Now, you can see the square starting to form and you can do the other 2 points down there at the bottom. And then our square has been reflected over the y-axis. Now let's work with our lime green triangle that we have over here, and we're going to reflect this figure over the y-axis. Now what I notice is that this figure is to the right of the y-axis, so if I reflect it, it's going to end up over here on the left-hand side. So let's start with this point down in the bottom corner here. That point is 5 units to the right, so I'm going to go 5 units to the left as well. So my point is going to end up right here at -5. Now my second point at the base of the triangle here is 6 units to the left, so I'm going to go 6 units to the right, and it's going to end up here. And then the top point is 5 units to the right, so I'm going to go 5 units to the left, put my point here, and draw in my triangle. Now let's continue with the last 2 figures down at the bottom. We'll look at our teal triangle right here. Now, I notice that this figure is to the left of the line of symmetry or line of reflection, so I'm going to go to the right here. So my first point is 2 units to the left, so I'm going to go 2 units to the right. The second point is 3 units to the left, so I'm going to go 3 units to the right. And the last point is 3 units to the left, so I'm going to go 3 units to the right. Notice that my vertical distance hasn't changed. Your points need to be in line with each other, and depending on which axis you're reflecting over will depend on how they are even here. But because we are reflecting from left to right, the vertical distance in your figures should not change. So they should be on level with each other when you create those resulting points. Now, our last figure that we have is this little L-shaped figure. So our first point, which is right here, is the point I'm going to start with. It's 4 units to the right, so I'm going to go 4 units to the left, and I'm going to put my resulting point. Let me make sure that's in line. Now, my second point, which is right here, is 6 units to the right, so I'm going to go 6 units to the left, create my resulting point. Next up, I'm going to do this point down here, which is 4 units to the right, so I'm going to go 4 units to the left. Then 5 units to the right, so I'm going to go 5 units to the left, and then I'm going to put that last little point to create my L-shaped figure here. And I'm going to draw that in. Now, in our next example, we are asked this time actually to reflect over our x-axis instead of our y-axis. So remember that it is critically important for you to identify the axis you are reflecting over before you start the problem. Because if you are reflecting over the wrong axis, your resulting image is completely wrong. So make sure you identify that axis of reflection or line of reflection. So my line of reflection is at the x-axis, which is right here. So instead of reflecting left to right, this time we're going to be reflecting top to bottom. So I'm going to start with my brown triangle here. And what I notice is that my first point is 1 unit above the axis. So the opposite of 1 unit above, if I reflect, is 1 unit below. So my first point is going to be right here. The second point is 2 units above, so I'm going to go 2 units below. And same thing with that third point on my triangle. It is 2 units above, so I'm going to go 2 units below and then draw in my triangle. Now, same thing with my pink square here. So this square is at 3 and 4 units above, so I know that I'm going to be going 3 and 4 units below. The squares are pretty easy to draw because they take up just one single box. So I'm at 3 units, 3 units, 4 units, 4 units, and then I can draw in that square. Now, next up is the red square, which is down here at the bottom. So it's our first one that's actually below the x-axis. So because it's below, it's going to end up reflecting above the axis here. So my first point is 1 unit below. So I'm going to go 1 unit above. Then 2 units below. So I'm going to go 2 units above for each of my left and right corners there. And then 3 units above to complete that square. And I'm going to connect my points to create that figure. Now, the last one that we have is a little bit different because it's actually connected to the line of reflection. If a figure is connected to the line of reflection, then what happens when you reflect it is the figure is actually going to connect to itself. These 2 points right here, these bottom vertices of this triangle, I can't reflect them because they're right on the line of reflection. So those points are actually going to stay right where they are. Now, the point that I can reflect is the one that's at the top, and that point is 2 units above the axis, so I'm going to go 2 units below the axis to create that reflection, and I'm going to connect my lines to form my triangle. Now, this is where we get to something a little bit different because our line of reflection isn't one of the axes. It's actually a line that is through the coordinate plane off of the axis. So we are asked to reflect over the line y is equal to -1. So the first thing that we've got to do is think about where the line y is equal to -1 is located. And I know that the line y is equal to -1 is going to cross the y-axis at -1. Therefore, it would have to be a horizontal line straight through here. So I've taken my highlighter and I've drawn in that line of reflection there. Now, once you have the line drawn in, this is where the tricky part occurs because a lot of students want to go back to the axis and they see, let's say you're starting with a square, they see that this is 2 units away from the axis. We're not reflecting over the axis, so this axis means nothing at this point. We are focusing on this line of reflection right here, which is the reason I highlight it. So when you are determining where your reflection is going to be located, you've got to focus on that piece there. So what I notice is that if I'm starting with this purple square right here, that bottom right corner right there is 1, 2, 3 units above. So I'm going to go 1, 2, 3 units below. Now, notice that when I went 3 units below, I did not start from the axis and count down. I started from my line of symmetry and counted down 3 units. So the distance should be the same above and below this blue line, not the black line. Now, same thing with the other points on my square here. And I'm going to complete out those 4 points. And there is my purple square. Now, for the green triangle, this one is a little bit easier because it's a little bit closer to the axis. So if I look at my green triangle, both of these points are 1 unit below the axis. So I've got to make sure I go back to my line of symmetry here, and I go 1 unit above that axis or line of symmetry. So my resulting points are going to end up here and here. And then the top vertex of my triangle is going to be 2 units above the x-axis there. So there is my green triangle. Now, looking at the blue figure that we have here, this one again is going to be actually, I think, a little bit easier because it's connected to the line of reflection. So that means 2 of the points are going to stay right where they are. These top 2 vertex points here are going to stay right where they are. And then the figure is going to flip up. So this point here is 1 unit below. So I'm going to go 1 unit above, which is going to put this point right here. This point is also 1 unit below, so I'm going to go 1 unit above. And then these 2 points right here are 2 units below, so I'm going to go 2 units above for each one of those, and you're going to notice it meets up with that orange triangle right there. And I'm going to connect those points to make that little L-shaped figure. Now, last one that we have is our orange triangle there. Let me get my orange marker here so I can have it match. And with the orange triangle, what I notice is that the bottom 2 vertices are 1, 2 units, 1, 2 units above the axis of symmetry or line of symmetry. So I'm going to go down 1, 2 units below and 2 units below to create those 2 vertices at the bottom there. And then my top vertex on that orange triangle is 1, 2, 3, 4 units above the line of symmetry. So I'm going to continue 1, 2, 3, 4 points below. And I'm going to connect those pieces together to form my triangle. So last thing that we're going to do here is we are actually going to draw in the line of symmetry for each one of the matching figures. So basically when you're trying to find the line of symmetry, you want to figure out where the line would divide the figures evenly. So you want to find the line that is directly in the middle. It's kind of just a visual thing. You can count it out in order to figure it out, but most people can just look at a pair of figures that have been reflected and find the line that is directly in between them. So let's start with our purple triangles here. And if I look for the line that is directly in between my purple triangles here, that line is going to be right in here. So my line of symmetry would be at y is equal to +2, because that line is going to cross the y-axis at +2. It will continue on. I'm just stopping it here so that I don't have lines just going all over my screen here. Now let's go ahead and look at the yellow set of squares here, and I'm going to use orange instead of yellow because yellow doesn't show up very well. But if I find the line that is directly in between the 2 yellow squares right here, of course it's going to be right there in the middle. And what I notice is that that line right there is going to cross the x-axis at +4. So the equation of that line is going to be x is equal to +4. Now, next set that we're going to do, we'll do the blue trapezoids that we have here, which are these 2 figures right here. And for this one, I'll probably have to count because the figures are a little bit further apart than the other sets. So if I count, starting over here at the left one, they are 1, 2, 3, 4, 5, 6, 7 units apart. So halfway, if I'm talking about 7 units, would be 3.5 units. So what I'm going to do is I'm going to count over 3.5 units from the left-hand side here. So 1, 2, 3.5 is going to be right in between that 2 and 3 here. So the line is going to be right here. And it hits the axis at 2.5, so it's going to be x is equal to 2.5. That's the equation of that line. Now, next pair that we're going to look at, and we will deal with actually the green triangles that are here, and then the red triangles that are here and here. We'll deal with them a little bit later in the lesson. We're going to focus on the straight lines first, and then we'll look at the diagonal lines in a minute. But the last set that we're going to look at are these grayish, bluish squares that we have down here. And I'll just use a black line for that. And they're 1 unit apart, so of course the line, if I can draw it straight, is going to be halfway in between. And that line is going to cross the x-axis right here at negative 5.5. So the equation of that line is going to be x is equal to negative 5.5. Now on the back side, we are going to start working with actually reflecting full figures using coordinates and working with that reflection rule. And so in this figure here, we have triangle ABC, and we are told in the problem that we want to reflect this figure over the x-axis. And gray highlighter's probably not the best color, so we'll do that in purple. So what we want to do first, as we did on the front side, is you want to make sure that you find that line of reflection there. So we are reflecting over the x-axis here, so I've highlighted that line of reflection to make sure that I am looking at the appropriate line. So what we want to do is we want to find the new coordinates of triangle A prime, B prime, C prime. Now remember yesterday we talked about the prime notation. Remember that little apostrophe or prime notation means that a reflection or some other transformation has taken place. It can be any one of our transformations. So let's go ahead and reflect this figure here. So what I noticed for point A is 5 units above this line of reflection. So I am going to go 5 units below that line of reflection, and I am going to end up with point A being right here, and I am going to label that A prime. Now for the second point, which is point B, that point is 3 units above the line of reflection, so I'm going to go 3 units below. So B will end up right here, and I'm going to label that B prime. Now, you will notice in this particular question that the line of reflection goes straight through the figure. If that happens and your line of reflection goes through the figure, you will be reflecting in opposite directions. So these 2 points were above the line, so they ended up below the line. This point down here is below the line, so it will end up above the line. So what I notice is that C is 2 units below, so C prime is going to end up 2 units above. And then I can connect my points to make my triangle. And my points aren't connected very well, but you have a ruler, so you can do much better. So now what we want to do is we want to write a reflection rule based on the relationship between the original coordinates and the new coordinates. So let's look at the coordinates of point A. The coordinates of the original point A, which is up at the top, are -3, +5. The coordinates of A prime, which is down at the bottom, is -3, -5. Now, what we're looking at is the relationship between the coordinates of the original and the coordinates of the new one. So when we start to write our reflection rule, just like yesterday, it's every xy is transformed to some new value. Now, let's look at the x coordinate. Did the x coordinate up here change to the x coordinate down here? Did it change at all between the 2 points? The answer to that is no. It was -3 up here at the top. It's still -3 down here at the bottom. So the x remained the same. So every x is going to stay x. Now, next up, what we're going to look at is what happened to the y. Now, the y started at +5 and went to -5. The number stayed the same, but the sign changed. Now, we know that in math, we change a sign by adding a negative to it. So every x stayed +x, every y became -y. Now, you can double check this on the other points. I'll double check it for the B here. You can check it for the C as well. But B is at 3, 3, and B prime went to 3, -3. So notice that every x stays x and every y becomes negative y. Now remember that if the y is already negative, then it will become positive. That's why the figure moved above, or this particular point moved above instead of below. So please remember that the negative y doesn't necessarily mean a negative number. If it was a negative to start with, it will become a positive. So next up we have quadrilateral A, B, C, D, and a quadrilateral is just a four-sided figure. And this time we are reflecting that figure over our y-axis. So here is our y-axis here. Now I'm warning you right now, if you do not pay attention to which axis you're reflecting over, you will end up getting your reflection wrong every single time. So what we're looking at is reflecting this figure. So point A is 2 units to the right, so I'm going to go 2 units to the left. Point B is 5 units to the right, so I'm going to go 1, 2, 3, 4, 5 units to the left. C is 2 units to the right, so I'm going to go 2 units to the left. And D is 5 units to the right, so I'm going to go 5 units to the left. And I'm going to make sure I label my points here. So this is going to be A prime. This is going to be B prime. This is not C prime. Let me erase that, put that in the wrong spot. So we've got C prime here and D prime here. Now, once again, we're asked to write a reflection rule, so let's take a look at our coordinates. So I'm going to write them off to the bottom here so that you can actually see them because the two figures are too close together. So the coordinates of point A, the original point A, are at 2, 6. And the coordinates for A prime are at -2, +6. So what we want to do is look at the relationship between that original point and the new one. Now I'm going to start off my reflection rule with the correct notation. So xy gets transformed. And what I noticed that in this case, actually the x's are the ones that changed. My x became negative and my y stayed the same. So this time my x is going to become -x and my y is going to stay +y. So you'll notice the difference when you're reflecting over the x-axis, your y is actually the value that changes. When you're reflecting over your y-axis, your x is actually the value that changes. Now, for this next example, what we notice is that there is no figure drawn. So the first thing that I want to do is I want to draw my pre-image or my original figure. So point A is at +1, +1, 2, 3. Point B is at +1, 2, 3, 4, 5, +2. And let me make sure that I label these. And point C is at +2, +1. So this is my pre-image or my original figure. Now, I am asked to reflect over x is equal to +3. Now, x is equal to +3 is a line that crosses the x-axis at +3. So I'm going to find +3 on the x-axis, and that is going to end up being a vertical line straight through x is equal to +3. Now, what I notice is this is like the first example where the line of reflection actually goes through my figure. So I know I'm going to be reflecting in opposite directions. So, for example, these 2 points right here are on the left side, so they are going to end up on the right side. This point right here is on the right side, so it's going to end up on the left side. So this one's going to get a little bit tricky because you are going to have the figure end up pretty much lying on itself, but flipped in a different direction. So let's take a look at what happens. So starting with point A, I noticed that point A is 2 units to the left, so I'm going to go 2 units to the right, and there is A prime. B is 2 units to the right, so I'm going to go 2 units to the left, there is B prime. And then C is 1 unit to the left, so I'm going to go 1 unit to the right, and there is C prime. I'm going to connect those points together. And then I have my resulting image. Now, instead of writing a reflection rule for this one, I actually ask you to answer the question down at the bottom here, which is triangle ABC congruent to triangle A prime, B prime, C prime? So I'm asking you if the two triangles are congruent. Well, I can clearly look at these two triangles and see that they are the same size and the same shape. One has just been flipped over. We had a name for that we talked about yesterday. So my answer is going to be yes, they are congruent. They're the same shape and the same size. And the word that we used, or the term that we used yesterday, was the term rigid motion. Remember, the term rigid motion means that a transformation has taken place that results in two congruent figures. Now, next example that we have is actually the same exact triangle, but we're just reflecting over a different line. So the first thing I'm going to do is redraw that triangle. So A is at +1, 1, 2, 3. There's my A. B is at 1, 2, 3, 4, 5, 1, 2. And C is at 2, 1. Now, this time, instead of reflecting over a line that is x is equal to, we're reflecting over a line that is y is equal to this time. So we're reflecting over y is equal to +1. So I'm going to find +1 on my y-axis, and that's going to create a horizontal line straight through my graph here. Now, what I notice is that this line doesn't go through the triangle, but it does hit one of the points. So one of my points isn't going to move. It's going to stay right there at that point. So let's start with A. I notice that A is 2 units above that line, so I'm going to go 2 units below. B is 1 unit above, so I'm going to go 1 unit below. And let me label these A prime and B prime. And then C prime is right on, or C is right on the line of symmetry, so C prime is going to stay right there at the same point. So C and C prime are the same point. Connect my points and I create my triangle there. Now, down at the bottom, it asks, is this an example of an isometry? Now, remember, an isometry is the same thing as rigid motion. It's just another name for it. And remember, an isometry or rigid motion means that the two figures are congruent to each other. So it's a transformation that produces congruent figures. Now, of course, the answer is yes. And the reason being is that triangle ABC is congruent to triangle A prime, B prime, and C prime. Now, there are some special lines that we reflect over, which the rules are a little bit trickier and it's a little bit harder to reflect over these lines. So what we have are a set of rules that help us determine what the resulting location is going to be. So for each one of these, it covers a different line of reflection. So let's take a look at the rules that we have here. This is if it is reflected over the x-axis, which we already know how to do, so we really don't need that rule right there. This one is a reflection over the y-axis, which we know how to do, so we don't really need that rule. But the line y is equal to x and the line y is equal to -x, these are a little bit trickier. These are the diagonal lines that go through the origin, so that's y is equal to x right there. And then y is equal to -x would be the diagonal line slanting down, which we'll look at in a minute. So there are some special rules that apply to these, and you'll want to keep these rules handy because generally I find it easier to reflect if I know the rules for these two. I do not use the rules for the first two, but I do use the rules for the last two. So if I'm reflecting over the line y is equal to x, which is that diagonal line with a slope of 1, then my rule is B, A. Now what that means is I'm swapping the x and the y coordinate. I'm just switching them. So the original coordinates will swap places. Now, if I'm reflecting over the line y is equal to negative x, I'm still swapping, but they're both going to become negative. So I'm going to change the signs on both of the terms as well because my slope is a -1 instead of it being a +1. So if you're reflecting over these two lines, make sure you swap the coordinates. If it's a positive x, keep the points as is. If it's a negative x, then you want to change the sign on all your coordinates. So let's take a look at what we're asked to do in this particular problem. So we are asked to reflect over y is equal to x. Remember, y is equal to x is that perfect diagonal line. And I'm going to try to draw it as straight as possible on the iPad here. So it's that perfect diagonal line that goes through 0, 0, 1, 1, 2, 2, etc. And I have my original points at 1, 3. And it would help if I was on the pen instead of the highlighter. And then B is at 5, 2 again. And then C is at 2, 1. Now, the rule for y is equal to x tells me just simply to switch my coordinates here. And let me finish drawing in this triangle before I move on. So what I'm going to do is I'm going to take all of my coordinates and I'm going to swap them. I will usually rewrite the coordinates so that I can just graph them. So A prime is going to become 3, 1. B prime is going to become 2, 5. And C prime is going to become 1, 2. So those are my 3 new points. So let's go ahead and graph those 3 new points. So over 1, 2, 3 and up 1. So that's A prime. Over 1, 2, up 1, 2, 3, 4, 5. And that's B prime. And then over 1 and up 2, and that's C prime. And I have my new triangle. Now, what you will notice is that that would have been very difficult to determine by just looking at the line and counting, but you notice that B is a perfect reflection. It's the same distance in either direction, but because the line is diagonal, I can't just simply count like I've been doing in the last couple problems. Same thing with point C, and same thing with point A. They are the same distance in the opposite direction, but it's a little bit harder to count because they are on a diagonal line there. Now, last thing that we're going to talk about is what is the connection between reflections and symmetry. There is something that is called reflectional or line symmetry, which is basically how many different ways or where could you cut the figure so that it looks the same on both sides or it is a reflection. So let's look at our figures here and let's determine where our symmetry would be located. So what we're going to do is we're going to draw in all of the lines of symmetry or the reflectional lines for each one of these figures. So looking at the triangle, the most obvious line of reflection would be straight down the middle. But there are also 2 other lines that you could draw. You can draw one from each vertex to the center of the opposite side. So this figure has a total of 3 lines of reflection or 3 lines of symmetry. Now for the square, I can cut it down the middle. There's 1 line of symmetry. I can cut it across the middle. I can cut it diagonally down one side, and I can cut it diagonally in the other direction. Now, what you should notice for each of the figures that we've worked with so far, the triangle, which has 3 sides, also has 3 lines of symmetry. The square, which has 4 sides, has 4 lines of symmetry. That's not a coincidence. What you're going to notice in a second when we go to work with the pentagon, which has 5 sides, it's going to have 5 lines of symmetry. So let's get to our pentagon here. So our first and most obvious line would be straight down the middle. And then I can turn my figure and work with each one of my vertices straight to the center of the other side. So far I have 2 lines of symmetry, 3 lines of symmetry, 4 lines of symmetry, and 5. So when you're working with what we call regular polygons, which are polygons that have all the same sides on them, so all the sides are the same size, the polygon will have the same number of lines of symmetry as it does sides. Now, what we want to do in these last 4 down here at the bottom is decide whether these figures have reflectional or line symmetry. So let's start with the American flag. Is there anywhere that I could cut this American flag where it's going to look the same on both sides? Either left, right, top, bottom. Can I cut it diagonally? And of course the answer to that is no, because if I cut it down the middle, I've got this blue star area over here to the left. I don't have a matching blue star area over here to the right. I can't cut it vertically either for the same reason. So this figure does not have reflectional symmetry because there is nowhere to cut this figure where it looks the same on both sides. Now let's look at the Canadian flag, which is next. The question is, does this have reflectional symmetry? And the answer is yes. This particular figure is going to have 1 line of symmetry, and that's going to be straight down the middle. And of course, the reason that it has a line of symmetry there is it's exactly the same on the left-hand side as it is on the right-hand side. So you've got red bars on either side, you've got your white area in the middle here, and then your maple leaf here can be divided directly in half, and it's the same on both sides. Now, looking at our Mexican flag, which is down here at the bottom, this one does not have reflectional symmetry because the left side is green and the right side is red, so I definitely wouldn't be able to divide it down the middle. And I can't cut it vertically because of this little emblem in the middle. The top of this emblem is not the same as the bottom. So this figure right here would not have any lines of symmetry. So the last flag that we're going to look at is the flag of England, and it is the one in the bottom right-hand corner. And this one does have some lines of symmetry. You will notice that the flag can be cut straight down the middle here. And it will be the same on the left side as it is on the right. And I can also cut it horizontally, and it will be the same at the top as it is at the bottom. Now, I have a lot of students that try to cut it diagonally. The problem with trying to cut it diagonally is that this is a rectangle. Now, on a rectangle, the sides are not the same lengths. So if I try to cut this diagonally, what's going to end up happening is this top piece that's here, I'm going to try to match with this side here, which they are not the same size. And this side here, I'm going to try to match with the bottom, and they are not the same size. So the 2 sets of sides are not going to line up. If this had been a square flag, then it would have worked, but it does not work with the rectangle. In the last example we have here, we are asked for each one of our figures here, what reflection will carry each figure onto itself. So basically, it's asking you, where is the line of reflection for each figure that would cut that figure in half or create 2 equal pieces. So let's start with the red pentagon that's in the upper left-hand corner. And let me get my red pen set up here. There we go. Now, on the red pentagon, what I notice is that the figure could actually be cut down the middle here. So in order to create a reflection, I would have to cut along this line right here. So what we want to know is what is the equation of that line that would create a reflection within the figure. So that line crosses the x-axis at -3. So the equation of this line is going to be x is equal to -3. Now, looking at the green trapezoid, we'll do the blue triangle last because that's the hardest of the 3. But looking at our green trapezoid that is at the bottom, Let me get my green pen ready. There we go. We are looking for the line that would cut this figure in half. Clearly, we cannot cut it horizontally because the bottom is wider than the top, but we once again can cut it straight down the middle here. So if I were to cut this straight down the middle, that line is actually the y-axis. So there isn't an equation for that. It's actually the full y-axis there. Now, the last figure that we have is our blue triangle, and this one is, I think, the most difficult of the three because you can't cut it vertically or horizontally. What you have to do is actually cut it diagonally. So what I noticed is if I went straight through this vertex, straight through the middle of the opposite side, that would actually cut the triangle into two pieces that were identical, or I could fold right along that line right there. Now, we talked about a minute ago with our special reflections that we can reflect over the line y is equal to positive x. Now, remember that y is equal to positive x is that diagonal line in the positive direction. Y is equal to negative x would be in the negative direction, so it would be slanting down. So now that we've gone over all of your examples here, you are going to want to get your homework and start working on that for the rest of the block.